Welcome to the second half of section 7.3. Today we're going to learn about why we are even learning about logs. What do logs do? What's important about them? Logs are the inverse of exponential functions. Here's a graph of both. This equation here is y is 10 to the power of x. That's an exponential function. Our base is 10. And we have our initial amount is 1, and our graph looks like this with exponential growth, and that we've looked at. Now, the inverse of that is y is log base 10 of x. Remember, this is the common log, which has that invisible base 10. And notice my x and y's switch places. And it reflects across that line y equals x. Remember, we talked about what inverses do. So the logs are inverses of exponents. That means eventually we're going to use logs to solve for unknown exponents because they're our way of inverting them, or sort of like undoing them. They're like exponents backwards. That's the idea of logs. So today we're going to learn how to graph them. How to graph a log. It seems confusing, but I'm going to show you a way that makes it, hopefully, pretty simple. I want to go back and explain a few details about these graphs. When we had exponential functions, remember our asymptote was y equals 0. Our domain was all real numbers, and our range is y is greater than or equal to 0. So think about what an inverse does. It should flip that. Notice now we don't have a horizontal asymptote. We have a vertical asymptote. And that vertical asymptote is x equals 0. That's the line that this approaches without ever touching, which means now it's not our range that's limited, it's our domain. In the logs, the domain x is greater than 0. And our range is all real numbers. So everything trades places because they're inverses. Okay, so let's walk through how to graph a log function. Here's one. Y is log base 3 of x. How would we go about graphing this? Now, the way to do it is just to remember what the parts of a logarithm is. In this case, the answer is always what our exponent is. Things are kind of backwards. In fact, if we changed this to exponential form, remember we blew up that log and the 3 swung over here, we'd end up with 3 to the power of y equals x, because logs are kind of inverses. That is what you're going to use to graph this. So you're going to build a table, but think logically. Always when we build a table, we start with our domain and we start with our x's. But remember, a log is an inverse of exponents. So to make this really easy, instead of starting with our x's, start with your y's. Use this form if you need to. If you need to, rewrite it. Use this form and then do your y's first, and then your x's, and then plot those xy's. So for instance, I'm going to do this to my y's. There we go. Because remember, in a log, the y's are the exponents. Or here we go. So 3 to the power of negative 2 would be 1/9. 3 to the power of negative 1 is 1/3. So our x is 1/3. See, they just switched places. The x and y's just switched places. 3 to the power of 0 would be 1. And this is 3, and this is 9. Now let's plot these points and see what they look like. I plotted those points, and sure enough, here is my log equation with a base 3. That's the secret to graphing these. Start with your y's, and then solve for your x's, and then plot the xy's like this. Notice the asymptote is a vertical asymptote at x equals 0. My range is x is greater than 0, and I'm sorry, I said my range. I meant my domain. My domain is x is greater than 0. My range is all real numbers. So my domain and range is kind of traded from what they are. You're going to be asked that kind of information. What's the asymptote? What's the domain? What's the range? What's the y-intercept? Before we had a y-intercept, now there is no y-intercept. Remember, our domain is x is greater than 0, so it does not intercept the y-axis at all. Okay, you know, with all these different functions, we have stretched, we've compressed, we've translated and shifted, we've done all this, we've flipped. Are these any different? No, they are no different. So we're going through we can do the same things we did before. Here is our parent function. Y is log base b of x, and the base changes, but otherwise this is it. How those transformations that we did before are just the same. For instance, if I have an A here, that's either going to stretch it or compress it. If it's negative, it will reflect it in the x-axis, so that you can still reflect it as well. Bigger than 1 stretches it, smaller than 1 compresses it. So we still have that factor, that stretch factor there. Anything put in parentheses with the x like this shifts it left or right. Same thing, notice the negative, it's going to go opposite to its sign. That'll shift it left and right. And then same as before, to shift it or translate it up or down, we would add or subtract, depending on if we're going up or down, plus k would do that. So the same exact transformations we did with all our other functions still apply to log functions. I'm not sure that you're going to be asked to graph a lot of these logs when they have these kind of transformations, but I'm going to show you how to do it anyway, just in case. What you will, though, I do know, you will have to explain how they compare to the parent function. For instance, if you have this function, how would it compare to the parent function? So first you have to identify the parent function, and that's just log base 4 of x. Log base 4 of x is the parent function. So what this function is log base 4 of x shifted to the right 3 and up 4. That's what this is, and that's how you would answer that question. But I'm going to show you how you would actually, if you are asked to graph it, how you would walk through that. Step number 1 is to start with the parent function, y equals log base 4 of x. And then to make it easier, if you need to, switch it to exponential. This means 4 to the power of y equals x. And now put -2 through 2 in the y's, and then build your table just of the parent function like this. So this would be 1/16, 1/4, 1/4, and 16. Now that's the parent function and where it would be. Now we're going to look at the transformations. This shifts it to the right 3. So take all your x's and add 3. So this becomes 3 and 1/16. This becomes 3 and 1/4. This becomes 4, 7, 19. There are your new x's. This translates it up 4. So take your y's and add 4 to your y's. This becomes 2, 3, 4, 5, and 6. And now you have these ordered pairs. 3 and 1/16 and 2, 3 and 1/4 and 3, 4 and 4, 7 and 5, 19 and 6. Plot those points, and it should be this translated to the right 3 and up 4. Now the question is, what does that do to the domain, the asymptote, the domain, and the range? So in this parent function, your vertical asymptote would be x equals 0. This is going to shift that to the right 3. Your new vertical asymptote is x is equals 3. That's the asymptote, x equals 3, which means your domain, all your x's are greater than 3. So instead of being x is greater than 0, your domain is x is greater than 3. Your range is still all real numbers. It will not affect your range. Be sure you understand that concept and that you can work on answering that, and I'll help you if you need it in class. Okay, how is the graph of this function related to the graph of its parent function? So you need to be able to identify the parent function. It's log base 2 of x. So this function here is log base 2 of x translated to the left 2 and down 3. To the left 2 and down 3. So this is left 2, down 3. What is now our asymptote? So now our vertical asymptote is x equals what? -2. -2. It's whatever would make this equal to 0. That's our asymptote, which means our domain is x is greater than -2. And our range is still all real numbers. And that's how you do it. Okay, your lesson check is how does this graph relate to the parent, the graph of the parent function? And how does it affect the asymptote, the domain, and the range? So bring that in. You don't have to show me the graph, just tell me how it relates to the parent function, and that'll be good for your lesson check. And that's it for this section. It was nice that it's just half of this section. So hopefully this makes sense to you and you can work with this, and I'll see you guys next time.